All right, we'll do a quick brief this morning. I wanted to get into some of the notes I posted from yesterday this morning, and we'll go into there because I'm actually getting into mass gap field theory stuff. And one of the notes I want you guys to keep into consideration with that material is that's we're talking 5, 10 years putting that stuff together, more like 15, trying to get it worked out and giving the tightest variation of that. So a lot of that falls off early on. But I wanted to give you that example here in the morning. When you're taking your stuff hopefully out the Fermilab. Now, mind you, I keep it between the margins. But for the most part, you get in there, damn, I'm a minute early on the clock, or the clock's out for some reason. And I don't mean to be the metaphysical version of that. I mean, there's a pretty physical thing about your world, and pay attention to the clock all the time, all the time. It's a lot. I'm not saying do that. I'm not saying if you don't got my physics, don't do my physics. Okay. It comes times about being single and shit like that, and again how that correlates the thing on the board in the morning. What you're thinking, how you're thinking it, why you're thinking that. As a psychologist, as a physicist, you got to know those neutrinos because they're the internal forces, magnetism. It's the temperature index that changes the Bose-Einstein condensate functionability or serviceability. Not that the superconductor floats on the nitrogen rail there, but if the temperature starts to give out, it falls off. When did that happen in the real world to the train on the tracks? Or you in the elevator going up? Einstein, Schrodinger, Planck, Newton. What happened in the stone mill? Some of those things are, catching Sheldon the other night. It's you looking for a challenge? Clock in. Every one of those rocks, you could do quantum physics like that, and then it just starts to become a state of all right. So then that's that. And what I mean by that is I'm graphing those things. I don't mean necessarily all right. Here's that cut coefficient. I already got that one. How does that turn to some weird physics now that I already got? All right, these are all the coefficients on time, adjustment, when I should cut off, when's the turbulent flow, when's laminar flow. That's that smoothness against any kind of downhill uh, what do they call them? They call them irrigation systems from Caesar, from stretching some with a 2% grade. You know what I mean? Like that is friction. It's turbulent flow. That 2% grade that resists no friction has a flood line, has levees and dikes and everything.